Once upon a time, there was a protocol called IGRP, which was a classful protocol. You remember when we learned RIP, by default it was classful. So you said version 2 to make it as classless. Same like that. IGRP was one classful because we don't want classful. That protocol now no more seen on the routers. You don't have an option of IGRP, only EIGRP now. Enhanced Interior Gateway Routing Protocol is the option now. Because the IGRP was classful, it is removed. The better version is Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol. The administrative distance of this protocol is only 90. Because it is Cisco's protocol, they have given comparatively, they have given small number. You see, OSPF, such a nice protocol, but 110 administrative distance is 110. RIP 120. EHGRP is only 90 because it's their own protocol. They give more importance. 90. Every protocol has got a metric. EHGRP also got metric. We learned about that. There are 5 key values, in which K1 and K3 are considered. What is K1? Exactly. What is bandwidth? The amount of data, number of bits that the wire can accommodate per period of time. You can say per second. The number of bits per second the cable can accommodate is what called as bandwidth. Some cables have got more bandwidth, like 10 gig. Some have got just 10 meg. 10 meg is very small than 10 gig. Say 10 gig, 40 gig, all coming now. 10 meg is very small. Anyway, bandwidth and delay. The metric of EIGRP is bandwidth and delay. Now, what is the delay means? The time taken for an amount of traffic to go from one end to another. See, when you have a broad road and a narrow road, the time taken will definitely vary. It won't be same, no? One is very broad road. The other one is very narrow road. And you're going in a car. Definitely there will be some delay in the narrow road. Every link has got such delay. Bandwidth versus delay will always be there. Not only this delay, even the impurities on the wire will cause the delay. See, when I throw the stone, definitely there is a delay. There is a time taken for the stone to fall on the ground. There is a time taken. I throw the stone, immediately it is not falling down the same millisecond. No. It travels in the air for some time. And because of the opposing force like wind, atmosphere, that reduces the speed and slowly it falls down. The stone falls down. And definitely there is a delay because of the friction of the air. If there is no friction, then the stone would have traveled in the atmosphere like a satellite traveling. Anyway, we are not going to that area. What I'm trying to say is every wire will have some delay. They will not have the same delay. If the bandwidth is different, definitely delay is going to be different. Considering this too, EIGRP calculates the metric. Why the other three are not considered is what we are going to discuss now. K2 is load. K4 is reliability. K5 is maximum transmission unit. We call it as MTU, maximum transmission unit, MTU. Why these three are not considered? First, let us take this two. If you notice a main road, wherever it is, main road. Right now it is 7:20 a.m. 7:22 a.m. The traffic now in the road is not the same at 5 o'clock. The load has been increased now. 5 o'clock the road was not used by most of the people. Very one or two few people were passing by at 5 o'clock. Means there was no load or less load. But now the load has been increased. And at 9 o'clock it will be much more increased. 8:30 it will be much more increased. What I'm trying to say, the load will keep varying. It won't be same all the time. Time to time it changes. Early morning, 5 o'clock, you might have said that road is reliable. Why? Because there is no traffic. But now you will not say that. Now you will not say that road is reliable. Why? Because the load has been increased. When the load is increased, the road is not reliable. When the load is keep on fluctuating, you cannot predict how long it will take for you to go to the other end. The reliability will vary. As the load changes, the reliability also changes. And I told you the load varies time to time. For example, in the network, right now no one will be in the office. Load is less. The reliability is high. But at 8:30 to 9, people started coming in. People start coming in and they start using their desktop, laptop. The traffic increase. It increases. It increases slowly. At 10:30, everyone has come into the office. The load is very high. And then around 12:30, the load gets decremented because some people go to lunch break. You know? So the load varies, reliability also varies. Now, if you take a decision based on the variable, for example, two paths to reach some destination here, let's say 1.1.1.1, router 1 has got two paths. Let's say the router says this is the best path. But when the load increases, the reliability decreases, load increases, reliability decreases. So immediately algorithm says, what is the algorithm EIGRP uses? Dual algorithm. Diffusing update algorithm. And this algorithm says, this road is not good. Let us take this path. Now after some time, when all the traffics are kept here, again this says, hey, here the load is again high and reliability is less. So let us jump back here. Again, after some time, it will come here. Again, it keeps shuffled. It keeps jumping between two paths. That is not good. Why, you know? When you jump between multiple paths, a lot of problem comes. The gateway need to be changed. When you are saying this is the best path, now this is the gateway. And this is the exit interface. When you say this is the best path, then this is the gateway. And this is the exit interface. So the CPU will be simply running because of you changing the path. There will be a delay. I have two children. One of my child, while going to the shop, she will fix her mind what to buy. She will know. She will go straight and look for that particular toy and she will take it. Finish. She will say, Daddy, this is what I want. Okay, take it to the billing section. But the other one is not like that. She will take one. This is the best for me. Like router 1 is saying, router 2 is the best path. After some time, she'll turn around and see something else. Ah, that toy is more colorful than this one. Then she will drop this one and she'll go to that one. She'll take that. And she'll say, I want this one. But after some time, she'll say, no, wait. I'll go to that section and see. She'll go and see. And she'll say, this is what I want, the third one. So what happens here? More time is taken. You cannot come out of the shop so soon. That's what I'm trying to say here. If you are using variables as a metric, what is variables? Changing time to time. If you are using variables as a metric, then decision cannot be made faster. You need constant values as metric. Bandwidth is constant. 100 feet road. Bandwidth is fixed. 100 feet, isn't it? 100 feet means 100 feet fixed. Delay in the road, fixed. That's the maximum delay the road can give even in the peak hours. But load and reliability varies. If you go this path, you can reach in 2 hours, whether it is traffic or not. Even if it is high traffic, no problem. You will reach in 2 hours. That's the fixed delay on that path. See, in some places, you will see roads well organized. Everyone will go minimum speed of 80 kilometers, and there will be a very nice divider. In such roads, you can go very long distance, like 500 kilometers easily. No delay, fixed delay. In your track, in your land, no one will come. No one will come in the middle. You will be keep on pressing the accelerator. No one will come in the middle because the lane for going, you have 1, 2, 3, and there is a nice divider. And then for coming also, you have again another 1, 2, 3. So no traffic jam. When the bandwidth is more, whether it is more or less in networking, the delay will be fixed. The delay will be constant. The delay will not change. Say, for example, metro trains. As soon as you get in, you will know at what time you will get down. Accurately sharp on time. The metro will reach the station. While getting in itself, it will say airport 20 minutes. And right at 20th minute, you will be there in the airport. EIGRP metrics are bandwidth and delay because they both are constant. They don't change time to time. But the load will change. So don't get confused with the load and bandwidth. Bandwidth will not change. But load will keep changing. Morning 5 o'clock, no load. No conception of bandwidth. Around 9 o'clock, high volume of traffic. More conception of bandwidth. That is load. So if load varies, reliability also will definitely vary, no? Nambaga Tanmai. Marikonde irukum. காரணம் பயனாளிகள் load மாறுகிறார்கள். பயனாளிகள் மாறும் பொழுது நம்பகத்தன்மை மாறும். பயனாளிகள் குறைவா இருக்கும் பொழுது நம்பகத்தன்மை அதிகரிக்கும். கூடும் பொழுது நம்பகத்தன்மை குறையும். Inversely proportional. When this increases, reliability decreases. When load decreases, reliability increases. So you cannot trust this variable as a metric. MTU is maximum transmission unit. How much I can transmit? What is the size of the packet that I can transmit? That is what MTU. So this is different. Bandwidth is how many bits per second I can send. That is bandwidth. But this is how big the packet can be. Maximum transmission unit. What is the size of the packet? Again, this MTU is also constant. Like bandwidth and delay, this is also constant, but still we don't consider this. Why? We already have two constants. Okay, so EIGRP metric is only K1 and K3. K1 is bandwidth, K3 is delay. Next. EIGRP is a classless routing protocol, as I said. If it is classless, then it will support what? Variable length subnet mask, VLSM. In subnetting, we do subnetting based on the number of hosts per department. That is what VLSM, variable length subnet mask. We are not doing common subnetting for all departments. Depending on the requirement, we do subnetting. So the subnet mask will be, for some department it will be /24, for some it will be /28, for some it will be like 18, varies. EIGRP supports this. And EIGRP supports unequal cost load balancing. Balance. Unequal cost load balancing. Meaning what? If you have multi-path with equal metric, let's say this side also 10, this side also 10 metric, then it is equal cost. When you have equal cost, even if you take RIP, equal cost load balancing is supported by default. If I have more links of equal cost, only 4. Which 4? Any 4. Randomly it will take. So when you have multiple paths of same cost, 4 paths will be used to share the load that's supposed to go. If you wish to increase, you can increase. Only 4 can be sent at a time. Only 4 packets. Sorry, only 4 paths can be utilized. You can increase if you want. There is a command called max path. What command? Max path. Using max path command, you can definitely increase the number or decrease the number. Default is 4. Every protocol supports this equal cost, but only this EIGRP can support unequal cost load balancing. Unequal cost. Like 10, 11, 9. You see the cost is not same. So when the cost is not same, we call it as unequal cost paths. EIGRP can do load balancing, load sharing, even on these unequal cost paths. But this feature is not enabled by default. We have to enable by using a command called variance. So after we finish the first level of EIGRP, we will go to second level after finishing the all topics. Like we will be seeing this EIGRP in 2 levels. One is CCNA level. After that, all CCNA students will leave. And then again, this protocol will start in CCNP level with CCNA revision. So when we get into that CCNP level, we will be seeing this variance in detail, and then a lot of other things, very advanced things will be coming there on same protocol EIGRP. So we can do unequal cost load balancing, which is not at all available in any other protocol. The only routing protocol that is doing that supports unequal cost load balancing is variance. No other protocol supports this. But as I said, it is not enabled by default. Variance is not enabled by default. We have to enable it. Okay, next. As I was showing you other day in a small lab we did, I remember, where we enabled EIGRP on the same router where we were having RIP. And as soon as I enabled EIGRP, you saw the routes turned into D from R. R means RIP given routes, D means EIGRP given routes. The D in EIGRP stands for dual, diffuse update algorithm. What is this algorithm for? It is to find the best path using the bandwidth and delay. It finds the best path, meaning it generates the metric when you have multiple paths. It generates the composite metric and compares the composite metric. The path with the low metric is finalized as the best path by this protocol. So dual algorithm's job is to select the best path by comparing the metric. To calculate the metric, the algorithm used is dual. So dual is the algorithm. The job of this protocol is to compare the paths, composite metric. Composite metric is calculated based on bandwidth and delay. Compare the composite metric of paths to the same destination and pick the one with the less small value. Dual diffusing update algorithm. That's why in the routing tables we see D. Now, I told you the administrative distance of EIGRP is 90, but there's also one more, 170. 170 is very big. RIP is 120 only. So 170 is very, very less considered. Then what is this 170 in EIGRP? It's called external aid, external routes AD. AD for administrative distance for external routes. This AD is internal. What does that mean? It means when you advertise a network inside EIGRP, going under router EIGRP, you are advertising. Usually we do that internal only. On the other day, when we did the lab, we used the network command to advertise. Same like RIP only we used, you remember? Network command. That is internal networks. When you advertise using network command, EIGRP will distribute the routes as internal. But instead of advertising, if you redistribute, what is redistribute? Say, for example, you take the routes from RIP and give it to EIGRP to use. We call it as redistribution. Those redistributed networks are in external networks because it's not coming from EIGRP. It is originated from RIP, later injected into EIGRP. Let me tell it again. If the network is originated in EIGRP itself, then it is internal. If the network originates in some other protocol and you take it and redistribute it into EIGRP, those networks are external. For external, it is 170. Let me repeat 170 external once again. ரிப்பில் பிறந்து வருகிறதான நெட்வொர்க்கை EIGRP-க்குள் செலுத்தும் பொழுது EIGRP அதை எக்ஸ்டர்னல் நெட்வொர்க் என்று கருதும். கரெக்ட் தானே? அது EIGRP-ல பிறந்தது அல்லவே. அது ரிப்ல தான் பிறந்துச்சு. If the network is locally advertised, means if it is advertised in EIGRP, if the EIGRP is the reason for the network distribution, then it is internal. Rather, some other protocol advertised and EIGRP took it and EIGRP is now distributing. In that case, it is considered as external. So internal is 90, external is 170. So more about this external is coming in next level. I don't want really to focus right now on external. Just focus only on the basic EIGR. We have to get master with basic first. But I just want to give you why it is called as external. I want you to know in this level itself why EIGRP has got two administrative districts. In RIP, you don't have such numbers. Only one. In RIP, it is only 120. Administrative distance is 120. Whereas in EIGRP, you see, you got two. 90 is internal, 170 is external. Protocol, as I said, it is classful, but it will do auto summarization. What does it mean? If you will have some subnetted networks like 10.1.0.0/16, 10.2.0.0/24, 10.3.0.0/21. While advertising these three networks, it will advertise 10.0.0.0. This is what summarization. Automatic summarization. R1 will not advertise these three things individually. It will summarize to classful major network and send it by default. This is by default behavior. Auto summarization is by default. But in the newer version, it is cancelled. It is not enabled. It is not on. If you want, you can on it. I repeat. The popular version, the classical versions, which we were using for a long time, in that auto summarization is on, meaning it will summarize and send. What is the advantage of summarizing? The bandwidth that will be consumed for sending the update will be less. Another reason is on the receiving router, when it receives only one update instead of three separate updates, when it receives only one update, the CPU utilized, the time taken will be less. Not only that, the routing table will also now need to maintain only one route to reach these three networks, one summary route. So the routing table buffer is not consumed much, bandwidth is not consumed much, CPU is not going to be utilized much. These are all the advantages of summarization. By default, EIGRP and RIP version 2 will do what? Automatic summarization. Oh, boy, you remember that command? We used to type no auto summary. Auto summarization is good, but in some cases, we want to learn the detailed routes from R1. In that case, you say what? No auto summary. So this is applicable for both RIP version 2 as well as EIGRP. But in the newer version of EIGRP, they have cancelled this. By default, it is no auto summary in the new version. How do you know whether it is new version or old version? See, the operating system version, if it is 15 or later, then it will have EIGRP also newer version, in which auto summarization is off. If your operating system is 12.4, 12 dot something, or if it is before 15, you can say. Actually, 12 அப்புறம் நேரா 15 வந்துட்டானுங்க. 13, 14 அவங்க மிஸ் நட்டல போடுறது எல்கேஜி படிக்கும் போது அவங்களுக்கு. அதான் உண்மை. So, if you will see any version before 15, usually it is 12.4. As I say, that LKG teacher did not teach them, the developers, version 13 and 14. So, don't get confused. You will not see 13 and 14. You will see 12 version, 12.4, 12.1, 12.12. Or 15.1, something like that. Now, coming back to the original story. 12 dot versions and all will have automatic summarization on. What does that mean? In the older versions, you will not get detailed route by default. You will get only summary route. Only one route. Only one route, summary route. Which is considered as good on those days. But later they thought, nowadays routers are having very big processor, more buffer, more bandwidth. It is okay. Why do we need to summarize? So they made it as off. So now it is coming like 10.1, 10.2, 10.3 in detail without summarizing. So you will have all detailed routes now because it is off. But today, if you want to on it, you can on it. Simple. Go and type this command in the newer version auto summary. Then this will not be 3 or 4 lines of update. It will be only single line of update. That's summarized. Did you understand auto summary? அங்க இல்ல ரவுட்டர் EIGRPன்னு உள்ள போயிட்டு அங்க பண்ணணும் மாஸ்க் அப்படி இல்ல no, no, no. There is no connection between interface and EIGRP. In EIGRP you can give uh, whether it is off or on. You can have this one on the interface, no problem. No problem. You see 16, it's not classful. 24, it's not classful. That doesn't matter. While advertising, if it is on, it will summarize and on. It will accept what you give, but while giving to others, it will summarize and give. புரிஞ்சா? இப்ப பாருங்க, இன்ஃபர்மேஷன் கொடுக்கும் பொழுது ரவுட்டர் 1 ரவுட்டர் 2 கொடுக்கும் பொழுது நீங்க இன்டர்ஃபேஸ்ல கன்ஃபிகர் பண்ணியிருக்கிற சப்நெட்டட் இன்ஃபர்மேஷன்ஸை சொல்லாம சமரைஸ்ட் டிஃபால்ட் மாஸ்க சொல்லும். எப்போ சமரைசேஷன் ஆனா இருந்தா. சமரைசேஷன் ஆஃப் பண்ணியிருந்தா சொல்லும் பொழுதே இந்த 3 சப்நெட்டட் ரூட்ஸையும் தெளிவாக சொல்லும். உங்களை கன்ஃபிகர் பண்ண விடும் அதெல்லாம் கிடையாது. அந்த மாதிரிலாம் எதுவும் கிடையாது. நீங்க கன்ஃபிகர் பண்ற சப்நெட் எந்த சப்நெட் மாஸ்க்னாலும் கன்ஃபிகர் பண்ணலாம். அதை அனுமதிக்கும் இன்டர்ஃபேஸ் கீழே. இங்க EAGRP ரன் பண்ணும் பொழுது இது எப்படி சொல்லணும், எப்படி சொல்லக்கூடாது, சுருக்கமா சொல்லணுமா விவரமா சொல்லணுமா, அதான் இப்ப பேசிட்டு. நியூவர் வெர்ஷன்ஸ்ல விவரமா சொல்லும். பழைய வெர்ஷன்ஸ்ல பேண்ட்வித் வேஸ்ட் ஆகுது, டைம் எடுத்துக்குது, சிபி ரொம்ப ஜாஸ்தி கன்சியூம் பண்ணுது, இந்த காரணங்களுக்காக ஓல்டர் வெர்ஷன்ல சுருக்கமா சொல்லும். ஓல்டு வெர்ஷன்ல சுருக்கமா சொல்லும், நியூவர் வெர்ஷன்ல டீட்டெயிலா சொல்லும். ஏன்னா நியூவர் வெர்ஷன்ல புது புது ரவுட்டர்லாம் ரொம்ப சிபியூ ஜாஸ்தி வச்சுலாம் வந்துருச்சு. அதனால EAGRP கன்சியூம் பண்ண போற சிபியூ ஒன்றும் பெருசா ஒன்றும் ஜாஸ்தி ஒன்றும் டைம் எடுத்துக்க போறது இல்லை. ஏன்னா பெரிய பெரிய சிபியூலாம் வந்துருச்சு, பெரிய பெரிய பேண்ட்வித்லாம் வந்துருச்சு. அதனால ஓகே டீட்டெயிலா அனுப்பலாம், தப்பு இல்லை அப்படின்னு முடிவு பண்ணிட்டாங்க. பட் when you consider to summarize, you can do that. இல்லைங்க எங்க EAGRP பண்றது புரியல, அப்படி டீட்டெயிலா அனுப்ப வேணாம், ஏற்கனவே ரவுட்டர் ஸ்லோவா இருக்குது, சிபி ரொம்ப பிடிக்குது, பலாயிரக்கணக்கான நெட்வொர்க் வருது, ஏதோ 10 நெட்வொர்க் வந்துச்சுன்னா பரவாயில்ல, டீட்டெயிலா பலாயிரக்கணக்கான நெட்வொர்க் டீட்டெயிலா வருது, சம்மரைஸ் பண்ணணும்னா பண்ணிக்கலாம். ஆட்டோ சம்மரைஸ் பண்ணிக்கலாம். சரியா? ஓகே. So next one is EAGRP works only in autonomous group. Meaning, what is autonomous system first? Autonomous system in networking is identified using a number. The number can be any number between 1 to 6, 5, 5, 3, 5. And what is autonomous system? Group of router under a single technical administration. Group of routers under single technical administration. Group of router under single technical administration. Single technical administration meaning what? All the routers will have same owner, same network policy, same administrator, same owner, same company, belong to same company. So EAGRP, you see, if you want to run, you need to provide the same number, autonomous system number. Here if you say 1, and here if you say 2, then they don't form neighbor. They don't form neighbor. When you say autonomous system number 1 here, like this router EIGRP 1, here router EIGRP 1. When you say same number and advertise the network here, this in the interface network using the command network, they form neighbor. Autonomous system number should be same. In order to form group, they only work in group, okay? EIGRP only works in group. The autonomous system number should be same to form group. How one router knows the other router's autonomous system number? See, first they will form neighbor. For that, they send a hello packet. In that hello packet, it will say, hey, I'm coming from autonomous system 1. The other guy will say, I'm also autonomous system 1. Come, I'll accept you as a neighbor. And this guy says, I belong to autonomous system 1. And this guy says, okay, I accept you as a neighbor. First, they form neighbor, and then only they will share all the route information. Yeah. So these hello packets are sent every 5 seconds. Even after forming neighbor, the hello packets are sent every 5 seconds. Even after forming neighbor, why should they send hello packets? That is to maintain neighbor. That is to say, I'm still alive. If a neighbor is not saying hello for 15 seconds, that neighbor is considered dead. 5 செகண்ட் ஒரு முறை ஹலோ சொல்லிக்கிட்டே இருக்கணும். அப்பதான் அவன் கொடுத்ததெல்லாம் இன்னும் இருக்குதுன்னு ரவுட்டிங் டேபிள்ல வச்சுக்கோ. Every 5 seconds, every router should send hello packets to guarantee that whatever I gave you before advertisements, they are still there and I'm alive. If a router fails to say hello for 3 cycles, which is 15 seconds, that router will be removed from the neighbor list. The router will not be considered as neighbor anymore. And the routes given by that neighbor will be thrown out. If any present, it will be thrown out. Usually, before the neighbor goes down, as soon as the network goes down, trigger update will come. I repeat, neighbor போற வரைக்கும்லாம் ரூட் வச்சுன்னு இருக்காது. ஒரு ரூட் போச்சுன்னா உடனே எல்லாருக்கும் அப்டேட் வந்துடும். ரூட் போயிடுச்சு ரூட் ரிமூவ் பண்ணிடுவாங்க ரவுட்டிங் டேபிள்ல இருந்து. ஒருவேளை ரிமூவ் பண்ணாம இருந்துச்சுன்னா ரூட் நெய்பர் போனதுன்னு தெரிஞ்சதும் அந்த ரூட்டை ரிமூவ் பண்ணிடும். 15 செகண்ட் வெயிட் பண்ணும். நெய்பர் ஹலோ சொல்லல, சரி அவன் கொடுத்த ரூட் ஏதாவது மிச்சம் மீதி இருக்குதா அதையும் தூக்கி போட்டு. So the hello packets helps to converge in one way. Usually the triggered update will converge. Converge என்ன சேஞ்சுக்கு ஏற்ற மாதிரி டப்புக்கு டப்புன்னு மாறிடுறதா கன்வர்ஜ். இடத்துக்கு ஏற்ற மாதிரி அந்த மாற்றங்களுக்கு ஏற்ற மாதிரி ரவுட்டை தூக்கி போடுறது, ரவுட்டை ஆட் பண்றது, அது பேர் தான் கன்வர்ஜன்ஸ். அதுக்கு triggered updates வரும். Triggered updates whenever there is a change, immediately the change will be notified. That is triggered update. That notification that will update. But the hello packet also helps to maintain the routes in the routing table. Because the neighbor is there, the route given by neighbor is also should be there. Okay. So the timers are 5 and 15. Okay. Much more things are there in EI